Hello, hello. Am I audible to all of you? Just let me check. Am I audible? Hello. All right. Okay. Sorry, there was some mic issues. Pardon me. So let's again start from the back part. Okay. So today we basically want to discuss about 3D geometry, right? So if you're someone who is new to this particular channel, so we are basically starting with a series where we are basically discussing about the different previous year questions from different topics of maths, right? So with this, we will basically try to help you out with your preparation on your CBSE board examinations, right? So today we'll start with the topic of 3D geometry. So if you're someone who's new to this channel, so we have already covered the lectures of vectors, right? So if you have watched that, so let's start with the 3D geometry, right? So I will be the instructor for this course. And if you're someone new to this particular channel, please consider subscribing to the channel, and you can definitely find all the important upcoming contents on this particular channel. So please consider clicking on the bell icon and so not miss out any notification for this particular channel, right? So we will basically come up every day on this particular channel and we will discuss about different topics. Okay. Also, we will be also discussing some strategies and how to prepare or how to write your exam answers so that you get the full marks, right? So you don't leave any stone unturned, right? So with this, we basically are here to help you out with your preparation. So let's get started, right? So today our goal or motive is basically to understand the 3D geometry part with some previous year problems, right? So we'll basically see and understand the vectors and 3D geometry part. So in the last class we already covered vectors, and today we'll start with the 3D geometry part. And along with that, we also try to understand the direction ratios and direction cosines, right? I've repeated this particular topic in the last session. So if you're someone who has been watched the vectors topic, please go to the channel, and in the live section you will definitely find this video, right? After that, we basically start with applying the ideas of vectors to visualize the 3D geometry, right? This is a very important thing that you need to understand, that the questions of 3D geometry are very simplified and solved using the use of vectors, right? And that's we basically try to understand. So how we can basically convert a coordinate notations to a vector notation and vice versa, right? So we basically convert the Cartesian equation to the vector equation and vector equation to Cartesian equation. That's what we have to play with this chapter, right? Along with that, we also discuss about the techniques on solving different types of problems in the examinations, and we also discuss some of the exam patterns and paper analysis. That is very important and crucial, right? Because it's the ultimate final marathon of your preparation. So students who are basically haven't prepared the topics and are basically in a doubt that what they are going to do in the examination, so it is a very high time that you basically try to analyze the chapters strategically so that you are basically going to get the best output from it, right? So let's get started on this particular job. And today, at the very first note, we have a very simple problem with all of us. So now I would like to tell you something very important, that is that in a CBSE paper you will definitely have different types of problems, right? Some of them is a very simple 1 marker problem, some of them will be like 2 marker problem. So you will definitely combinations of 1 marker, 2 marker, right, and 3 or 4 marker problem, which are long questions, right? So these are the different types of sets of questions that you're going to encounter, right? And I know that definitely 1 marker problems are very simple, so students generally mark the answer directly to the option, right? But what I say that please do not write your answer like this, say question number 1, I got the answer as something as C, so the answer is C. That's not how you're going to do that, right? But instead of that, how will you do this so as to catch the eye of the examiner? The best strategy is basically to write the proper solution in a given proper manner, right? So what the question has to say is over here is that we have a point P with a given coordinate as, so I will first of all write given point P is given as a comma b comma c, right? So I have the given point which is given as a comma b comma c, right? And I need to find the distance of this particular point from the y-axis, right? Now let us try to understand how we basically take a distance from the given axis. So let us consider this is the x, y and z axis, right? It's a 3D coordinate space. So in this 3D coordinate space, I have any point in this 3D coordinate space. Let us say that particular point is basically in the first octant, and I call that point as a comma b comma c as p, right? So I need to find what is the distance from its y-axis, right? So I need to find this particular distance, right? Now there are multiple ways to solve this problem. Is that now simply what you can do, you can just assume a vector in the direction of y, right? Now that is the proper and the clear method to solve this problem. Now I know many people know the shortcut, so you definitely can move around with that, but I don't want to use that shortcut while I'm writing my answer for your CBSE board examinations, right? So So let's now try to understand that how we represent this, right? So I know that I can represent a y-axis as the follows, right? So let us consider any point that is lying on the y-axis is simply as origin, right? Origin is definitely lying on the y-axis. So what I will do, I will write the equation. I will write the equation of y-axis, right? I will write the equation of y-axis. So what is the equation of y-axis? The equation of y-axis is given as x minus 0 by 0 is equal to y minus 0 by 1 is equal to z minus 0 by 0, right? Now you must be wondering how it can denominator can be equal to 0, right? It is not like the denominator is equal to 0, it's just the direction ratios. So direction ratios along the y-axis can be given simply as 0 comma 1 comma 0, right? As simple as that, right? So therefore any point, any equation of y-axis can be simply written like this way, right? Now I just need to find out what is the distance of this point P from the y-axis, right? And what do I mean by distance is basically the perpendicular distance, right? So how do we go about solving this particular problem? Now, for doing this, let us consider that the distance of the perpendicular or the foot of perpendicular from point P to this y-axis be let a point, let us call that point as A, right? And origin is O, right? Now I need to find out what is the point A. For doing that, what I will do, I'll just assume any constant to the equation of the y, right? Now why I'm assuming this? So with this I will get a general notation of any point on the y-axis, and that is basically given as x is equal to 0, y is equal to lambda, and z is equal to 0. That's any general point on y-axis, right? So you know any general point on y-axis is going to be x equal to 0, z equal to 0, and y is equal to some lambda or variable lambda, right? Now this is something that you might be saying that you already know it, right? But I'm basically showing how we know it, right? That's the actual procedure. Okay, so I'm doing it step by step so that you do not miss out any marks on your actual CBSE examinations. Okay, so mark my words, your presentation skill actually matters. Okay, now if you understand this, let us say that this particular point we have, right? So we have the point A as 0 comma lambda comma 0, right? So what we do, we just try to make this a vector. Okay, so we just try to find out what is our AP vector, right? So if you just try to find out what is our AP vector, so AP vector will simply be equal to the position vector OP minus position vector A, right? So that is basically going to be equal to AI cap plus B minus lambda times of J cap plus CK cap, right? As simple as that. Now I know that this particular vector AP is going to be perpendicular to the vector OA, right? So what I will do, whenever a vector is perpendicular, so I'm writing over here, so whenever I know the vector is perpendicular, I'll just take the dot product and make it equal to 0, right? So from here I'll just take the dot product and I make it equal to 0. So from here I will get lambda into B minus lambda is equal to 0, right? So that's what I will get over here. So from here I'll simply get lambda square is equal to lambda times of what B, and from here I will get lambda is equal to B, right? I'll simply get lambda is equal to B, right? So now if I have the coordinate of point A as 0 comma B comma 0, so therefore I can easily find what is the distance of this point A to P. So the distance of this point A to P will be simply given as square root of A square plus B minus B whole square plus C square, right? So that is going to be my answer. That's going to be square root of A square plus C square, A square plus C square, right? So that is how you are going to basically understand the problem, right? Now you will be asking like, do we have to do this much of calculations, or do we have to show this much of steps for your 1 marker problem? And it's not exactly you have to solve all these calculations. What you can do, you can just directly write the equation of AP as this, and you can directly do these calculations and just get the value of lambda. Okay, now if you're showing the steps, you know what is that, since this is a very first problem, right? So whenever just you open your answer sheet, you will get the 1 marker problem at the very beginning, right? Now my advice is all of you to this, you know, the first impression is the last impression, right? So the way you basically denotes your very first starting of the paper, the way you are going to impress the examiner is basically matters a lot in getting your entire paper corrected, right? So it is always advisable to basically do some of the steps of manipulation so that you can show that you know the proper concept, you know everything, and you're basically marking the right answer, right? That will prove you. So even if you are not marking the right answer, maybe you mistakenly instead of C you mark the wrong answer D, then also because you're showing the steps, the examiner will consider you and might be very lucky that you might also get 0.5, right? Because of the steps, right? So you can understand that's what the advantage is, right? So definitely go with the steps. Okay, so I hope this particular steps is clear, and definitely whenever we need to calculate any point from any given axis, so that particular coordinate of the axis is basically missing in the square root of that particular term. Okay, so that's a shortcut technique, right? Many people know that, I definitely know that. Okay, so if this is clear, please give me a thumbs up. So the option is C. So the correct option is answer to this particular problem is option number C. That's our answer, right? Please give me a thumbs up if we are clear with this. Please let me know. All right. So I hope this particular solution was pretty clear. Okay. So let's move to the next problem. And next problem we have with us is basically a simple problem from a assertion reason based questions, right? So this was also a 1 marker problem, and this was asked in a CBSE 2024 paper with the assertion reasoning, right? So how we basically approach this problem, let us try to understand it. So now how will you approach assertion reason questions, right? That's the important thing. So do we have to write the entire problem? No, not exactly. What you can write is that you can write the assertion, you can write the reason. And if the reason is accurately giving the reason for the assertion, then definitely mark the option number A, which is saying that both assertion and reason are the correct, and the reason is the correct explanation of the assertion. Right. So let us try to understand what is this particular question is saying that. So if you just go to the assertion, let us try to read it. So it is said that a line in a space cannot be drawn perpendicular to x, y, and z axis simultaneously. Is it true? Let's see. So what the question has to say is that if I have a particular line in a 3D coordinate space, I cannot have this line simultaneously perpendicular to all three axes. So let us draw any line like this. So it cannot be possible that it is perpendicular to all the three axes. Is it true or not? Let's try to understand. So we know that a given line, so if I just say that a given line is this, right? So if I have any given point, first of all, try to understand with respect to point. Let us say I have a given point as given as a comma B comma C, right? And if I just join it with the origin, so I get a position vector of this point P, right? As simple as that. Now the angle this position vector makes with the x-axis is given as alpha, with the y-axis is given as beta, and with the z-axis it makes is given as gamma, right? So if we are given this particular three angles as alpha, beta, gamma, then we know that the projection of this particular OP line on this x-axis is simply going to be equal to a by square root of a square plus b square plus c square. And similarly, the projection of this OP line or the OP vector onto this y-axis is going to be b upon square root of a square plus b square plus c square. And similarly, on the z-axis, it's also going to be equal to c divided by a square plus b square plus c square, square root of that, right? So that's very simple, right? So from there, we have obtained in the last class that we know this very important relation, that is the direction ratios, or this is basically called direction cosines, right? Their direction cosine. So we know that this particular direction cosine, square of that and summing it up, it will basically give you 1, right? So we know this particular thing. Now let us say if a particular line is making 90 degree with all the three axes, then all of your alpha, beta, and gamma are simultaneously equal to 90 degree. So if alpha equal to 90, if beta equal to 90, and gamma equal to 90, then am I having this relation satisfied? So if I just put alpha is equal to 90, I will get it as 0, beta equal to 90, I will get it as 0, and gamma equal to 90, I will get it as 0. So is 0 equal to 1? No, 0 is not equal to 1. So therefore, our reason is extremely correct to explain the assertion that a line cannot be drawn in a series coordinate space which is perpendicular to all the three axes simultaneously. Right? Is this clear? Please let me know in the group chat if it is clear. Right. So therefore, our option number A is a very correct answer. That is, our assertion is basically correct, and the reason is also correct, and the reason is definitely the correct explanation of this particular assertion. Right. As simple as that. I hope this part is clear. Please give me a thumbs up if this is clear. So I'm waiting for your comments. All right. Okay, so this is clear, right? It's very simple, right? So you just use the concept of your direction cosine. So you know the relation of direction cosines. You just put the angle. So if it is 90 degree, then what is this relation is satisfied or not? And this particular relation is satisfied in all the cases, right? So it must be satisfied for a given value of alpha, beta, and gamma. And if this is not satisfied, then that particular line cannot be drawn, right? I hope this is clear, right? Let's move further and discuss about the next problem. And with this, let's move to the next problem we have with us. And this is a 3-marker problem, right? So this is a 3-marker problem. So if you try to understand the problem, let us try to read it. So the question says that we need to find out what is the image of a point x comma y comma z with respect to the line with respect to the line, and our line equation is given as x upon 1 is equal to y minus 1 by 2 is equal to z minus 2 by 3. Please don't consider z minus 2 by 3, okay, not 2 by 3, it's actually written as z minus 2 divided by 3, okay, it's basically given as this, okay, like this it is given, okay. So please just try to avoid what is the way it's written in the problem. So okay, so I hope this particular thing is simple, right? Now it is said that the image of this particular point P with respect to this particular line is given as, so image of P is given as, so I'm writing the image as P dash and it is given as 1 comma 0 comma 7, right? Now I have a very simple way. Basically, instead of giving you the direct point, it is basically asking that is the image is given, then what is the original point, right? So now whenever you are basically solving this problem, I would definitely recommend all of you to please make sure of the diagrams, okay? So you can plot a diagram so that it's simpler for you to understand as well as for the examiner to also understand, right? So what you can do, you can just draw a straight line over here and you can represent the equation of the line given like this, right? Right, so this is our equation of the given line, and I have a point P which is mentioned as x comma y comma z, and we have to find out, and we are also given the image of the point that is given as 1 comma 0 comma 7, right? These problems are given, right? Now what we basically do, we try to find out that we know that when it is an image, it is a perpendicular, right? So this particular line P dash is perpendicular to this particular given line. So what I can do is that, now there are a lot of ways to solve this problem, right? What you can do, you can just make this vector P and you can just make it perpendicular with this particular direction ratios, right? And also you just make the midpoint of this point P will definitely lie on this particular line, right? That is a very simple way to solve this problem, but I am basically going to do it by considering any general point on this particular line by considering some lambda, right? So any general point on this line is given as x equal to lambda, y equals to 2 lambda plus of 1, and z is equal to 3 lambda plus of 2, right? Any general point of this particular line given like this, right? Now let us try to make this any general point. Let us consider this general point is A. So if I try to find out what is our vector, P dash A, right? So we basically find this coordinate as simply as lambda minus 1 I cap plus 2 lambda plus 1 j cap, right? And plus 3 lambda minus 5 k cap, right? So this is how we will have the vector P dash A, right? Now we know that P dash A vector is definitely perpendicular. So this particular vector is perpendicular to this particular line. So I will just take the dot product with this direction ratio of the line. So I'm calling this line vector or direction ratio of the line as L vector. Okay. So this L vector should be equal to 0, right? So if we just perform this manipulation, we'll basically get it equal to 0. Right. So what is going, so from here I will get the value of this unknown, that is lambda, right? So instead of solving for the three variables x, y, z, so we are basically solving in terms of lambda. So we get the value of lambda, we just try to put it A as a midpoint of P dash, and that's how we get it, right? As simple as that, right? Now from here let us try to do the calculation. So I'm just erasing this part of the calculation. I hope you are also doing the steps with me, right? So let us see over here. So from here, if I just try to get back to this particular dot product, so the dot product is going to be lambda minus 1 times of A plus 2 times of 2 lambda plus 1 plus 3 times of 3 lambda minus 5 should be equal to 0, right? So if you just try to simplify, this is going to be lambda plus 4 lambda plus 6 lambda, 9 lambda. So that is going to be 14 lambda, right? And it is equal to, this is going to be minus 1, this is going to be plus of 2, so plus 1, and this is going to be minus of 15. Right, so plus 1 minus 15 is minus 14, so we take it on the right hand side, it's going to be 14. So from here we get the value of lambda as equals to 1, as simple as that, right? So once we get the value of lambda, we can definitely write the coordinate of A. So the coordinate of A is going to be equal to 1 comma, so the coordinate of point A, that was basically going to be 1 comma 3 comma 5, right? 1 comma 3 comma 5, right? Now in a given this particular relation, so while our line is the acting as a role of the mirror, so this particular point A is going to be a midpoint. So this particular distance should be equal to this particular distance. This by simply by following the law of reflection from the physics, right? We know that the distance of a point object from the mirror is equal to the distance of the image from its mirror, right? Now if we just apply the midpoint formula over here, so I will basically get our calculation simplified. So I will get x plus 1 divided by 2 is equal to 1. So from here I'll get the value of x equal to 1, right? So I will get the value of x equal to 1, and similarly if I perform the steps as follows, so I'll get y by 2 is equal to 3, so from there I will get y is equal to 6, and I'll get z plus 7 is equal z plus 7 divided by 2 is equal to 5, so that's how I will get z as basically 3. So that's how I'll basically come to the coordinate of point P, that is 1 comma 6 comma 3. So that's going to be a final answer, right? So the coordinate of point P is going to be equal to 1 comma 6 comma 3, right? As simple as that. So our unknown values of x, y, and z are basically simplified and calculated in the following way, right? Is this clear? Give me a thumbs up if this is clear. All right. The questions of mirror an image or the finding the footer perpendicular or finding the perpendicular distance of any point from a straight line in a 3D space is very important. Okay, these are very crucial. Okay, so you can also expect these types of questions to be also asked in a JEE mains, right? So students who are basically preparing for JEE mains, it's definitely a bonus for all of you, right? So you can prepare both the topics simultaneously, right? And don't worry, we're gonna definitely come up with some JEE mains previous year problems questions, right? So we're gonna also prepare and revise for JEE mains. Okay, so stay tuned for this channel, right? So don't forget to hit the subscribe button. Okay, I hope you all are subscribed to the particular channel, right? Okay, so I hope this particular question is simple and clear enough, right? So let's, with this particular problem, let's move to the next problem, right? Now we are basically to understand how to find out any, so this was all the questions that I basically see in the chapter of straight lines, right? So these are all problems. So you can see there were 1 marker problem, one more 1 marker problem, and one 3 marker problem, right? So you can see you have 3 questions, right? And also there were some problems from planes which I will take up in the upcoming questions. Okay, so let's move with this and let us try to understand from the basic part. So whenever you are given any straight line, let us try to understand. So if we are having a straight line in a 3D space, right? So it is basically a 3D space in a straight line, and let us say I know some point that is lying on the straight line given as a comma b comma c, right? And I know that this particular straight line is at a direction, is going in a particular direction, or is directed along a particular direction whose direction ratios are given as alpha comma beta comma gamma, right? So if I know this particular information, so from this particular information I can simply find out the equation of the straight line. How I can do that? The simple way to write is basically, let us consider any random point on this particular line, and let us consider that particular point or position vector that particular point as r vector, right? I can also write the position vector of this particular point as a vector, right? And I can also say that this particular direction ratios, let us call that as L vector. This particular line is directed along some particular vector, right? So in order to write the equation of any straight line, equation of straight line in space. So in order to write the equation of straight line in space, what I will do, I will just try to understand that what is the condition or criteria for a parallel line. So we know that whenever we have two vectors given as parallel, may not be their magnitude wise same, but their direction wise parallel, right? So this particular vector L1 is parallel to L2, then we basically write L1 vector as some multiple times of L2, right? That is what we basically have seen in the chapter of vectors, right? So similarly, to write the equation of a straight line, what I will do, I will just equate this vector. So let us equate this vector AR. So AR vector is going to be position vector R minus position vector A, right? Is equals to some constant, and I will call that constant as lambda. I call that constant as some lambda, right? So lambda times of L vector, right? Now from here, I'll get the general point R in terms of the known quantities. So I have the vector A as known, and I have the vector B as, or vector L as also known to us, right? We know the direction ratios, we know the point on the line. So now if we know the point of the line and the direction ratio, and just by changing this value of lambda, we will definitely generate different points on this particular straight line. And if I'm able to generate different points in this particular straight line, that is the definition of a locus, right? So if I'm able to satisfy the unknown quantity in terms of the given quantities, that's how I get the locus, and the locus is definitely going to represent the equation of this particular straight line. Is this clear? Please let me know if this is clear or not. Okay, fine. So therefore in order to write therefore I can transform this vector equation of a straight line. So this was a vector equation, okay? Now similarly I can transform this vector equation into the Cartesian plane. Cartesian coordinate notation is that, so what I will do over here, I have to find this unknown, right? So I will call this unknown vector in terms of x comma y comma z, right? That's how. And so it is basically going to be equal to x minus a divided by L, or I call this as alpha, right? The x coordinate of the direction ratio is given as alpha. So x by a is equal to alpha is equal to y minus b divided by beta is equal to z minus c divided by gamma, right? So that is how we basically get the equation of a straight line in the Cartesian plane, right? So once we understand this, let us see how we can basically find out the equation of this particular given things, right? So here we have to basically find out the equation of a straight line which is passing through the given point as, so here I have the given point as 3 comma 4 comma minus 7, right? And I have this point, second point, so this is point A, this is point B, so I have point B as 1 comma minus 1 comma 6, right? So I have the given points as the follows, right? So I have the given point as follows. Now in order to write the equation of this particular point, so I will have to find out what is the direction of the line, right? So the direction will be given by this simple AB vector, so which is basically founded as minus 2 I cap, right? Minus 2 I cap, and then I will have minus of 5j cap, then I will have plus of 13k cap, right? So that's what the direction of the vector, right? Or the line, right? So these are basically the given components are going to be the direction ratios, right? Now I need to find out what is my vector equation, right? So first of all, let us try to understand what is my Cartesian equation. So Cartesian equation, we can write this as simply as x minus 3 by 2 is equals to y minus 4 by 5 is equal to z minus or minus 7, so that's going to be plus 7 divided by 13 is my given equation of my line, right? But this particular equation is given in the terms of Cartesian plane, Cartesian notation, right? We just need to transform that back into the vector notation. So how we'll do that? We simply use this particular notation. So our vector equation of the line is going to be equal to a given point on the line in terms of vector or the position vector, that is going to be 3i cap plus 4j cap minus 7k cap plus some lambda times of r vector, and r vector is going to be simply this part, right? This a vector is going to be r vector, so this is going to be minus of 2i cap minus of 5j cap and plus of 13k cap. So that is going to be a vector equation of this particular line, right? As simple as that. So this was a 2-marker problem that was asked in the paper of 2020, right? So you can see how simplified these questions are, right? I hope this part is clear. Please give me a thumbs up if this is clear. Okay, is it clear to all of you? Please let me know. So I hope you have understood this particular problem. So definitely now it's time to let's move to the next problem, right? So you can see that there are simple problems that are basically asked in the CBSE exam. So once you are basically done with the basics, now none of the questions will going to be seeming difficult, right? So just take a note of this and please make sure that you understand and apply your concepts clearly, right? With this, let's move to the next problem, right? And with this, we have a next problem where we have basically said that, so let us try to understand what this problem has to offer. So the problem is basically saying that we have a line with given direction ratios with direction ratio 2 comma 1 comma 1, right? That's my direction ratio of the particular line, right? And I don't have any information about any point of the line. That's why I cannot write the given equation of the line, but I have only information about the direction ratios, right? And it is said that this particular line intersect the lines L1, which is given as x minus 7 upon 3 is equal to y minus 5 upon 2 is equal to z minus 3 upon 1. And similarly, I have the equation, the second line is given as x minus 1 upon 2 is equal to y plus 1 upon 4 is equal to z plus 1 upon 3, right? These are my equation of the given lines, which this particular line that I have. Now let us call this unknown line as some line L. Okay, so L intersect L1 as well as intersect L2 at given point. So it intersects the L1 at point P and it intersects the L2 point as Q, right? So we just need to find out what is the equation of the intercept PQ, right? So now you might be wondering like how we shall proceed with this problem, right? Now, what I would suggest is over here, let us try to understand what this particular problem has to offer. It says that we have two given lines like this and this, right? Now, one of the line is intersecting this particular line at some point P and at some point Q, right? But I have only information about the direction ratio. I have only information about the direction ratio that is given as 2, 1, 1, right? I have only the information about the direction ratio of this particular line. Now, using this direction ratio, how are we going to utilize this fact so as we can find the equation of the PQ line, right? Or the point PQ. Now, how you will basically approach this problem, let us try to understand. So, if I knew the entire equation of this particular unknown line, then the problem was very simple, right? We would just have equated the given coordinates, right, or the given points P to the one we are considering that if they're lying on the both the straight lines, then definitely they satisfy the equation of both straight lines, right? That's how we had achieved the problem, right? But what if it's not mentioned, and how are you going to proceed with this? So I just want all of you to please try to take a guess. Please try to take a guess, like what you basically going to see. So I'm basically looking for your chats. Let me know what you should do over here. Yes. So how are you going to proceed with this problem? This is a very interesting problem, right? Please let me know. I know this is a bit of tricky problem, right? So it might not click to all of you, but still give it a try. It's worth trying. Okay. No replies so far. Okay, so let's proceed with the problem. So let us try to see how we basically approach this problem. Now, let us consider any arbitrary point that is lying on this PQ line, right? So the simple way to do is basically you are just considering P point in terms of some lambda, right? Let us consider this some lambda and Q point in some times of some mu. So if we get the point P in terms of lambda and point Q in terms of mu, and just if we just try to draw this particular vector PQ, this is vector is going to definitely be parallel to this particular direction ratios, right? And that's how we're going to be achieving the convergence solution, right? So let us see. This is a very simple problem. I know this problem might be seeming very little tricky at the very first. That's why I give you time to think it out, right? Now let us try to understand what are we going to do. So any point of this P can be given as any point in this particular line L1 that can be a point P can be simply given as 3 times of lambda plus 7 is it comma 2 times of lambda plus 5 comma lambda plus 3, right? And similarly any point in this point L2 or Q can be given as 2 times of mu 2 times of mu plus 1 is equal to 4 times of mu minus 1 is equal to 3 times of mu minus 1, right? So this is how we will basically get the 2 points on the given line L1 and L2, right? Now we just need to subtract these 2 points, right? So if we just subtract, that means if I need to find out what is a vector PQ, I'll just equate that to, so just PQ vector is going to be equal to 2 mu minus 3 lambda 2 mu minus 3 lambda minus of 6 I cap, right, plus plus over here I will have 4 mu minus 2 lambda minus of 6 j cap, right, and plus, so I hope you are able to see the solution over here, right? So then plus I will have 3 mu minus lambda minus 4 k cap as the given PQ vector, right? So our PQ vector will be given in terms of lambda and mu. Now we just need to apply the concept that it is parallel to this particular direction ratio. So what we'll do over here, we just take the ratio of the direction ratios on of the PQ with the direction ratio of the given line, and just it will be maintaining the same ratio, right? So it is going to be like 2 mu minus 3 lambda minus 6 by 2 is equals to 4 mu minus 2 lambda minus 6 by 2 is equals to 3 mu minus lambda minus 4 by 1, right? And let us consider this particular ratios are all are the same, so we just need to solve any two of this given equation. So we have two unknown equations, so you just solve this first two part of the ratio and just put the value of lambda and mu in the second part. You're definitely going to get the relation. So if it is satisfying, you're definitely going to a closed form solution, right? So please give it a try. What are you getting? Let me know. So I am getting the value of mu. So what I have got in my solution, so from here I got the value of mu as minus of 2 by 3, and I got the value of lambda, sorry, I got the value of lambda as minus 2 by 3. I got the value of lambda as minus 2 by 3. Now this is something that you can definitely easily solve it by just by calculation. Okay, you have the two unknowns equations, right? So two equation, two unknown, easily solvable, right? And I got mu as 1 upon 3. Okay, so you can just check. You can just check with my calculations. Are you also getting the same answer? Are you also getting the same answer? Please let me know. Are you also getting the same answer? Please let me know. So I'm looking for your chats. Okay. So I hope this part of the solution is clear enough, right? Please let me know if you have any query or question. Okay. So this was a 5-marker problem. Okay. Now you might be saying like it's a important problem. Yes, it is indeed an important problem. It was a long answer question. Okay. Now many students were very confused like how to approach this problem, right? They were unknown that given the line equation was not given properly, and they had to find out the intercept, right? Now it is not totally done, right? We have the point mu, we have the lambda value, so we can definitely find for the distance of point. We can find the point P, we can find the point Q, and our distance of the point PQ. So our distance point PQ is going to be simply equal to the the coordinates of point Q minus square plus, sorry, this is basically the difference of the x coordinate of P and Q plus square of the difference of the y coordinate of P and Q. So I'm writing like this, yq minus yp square plus xq minus xp square plus plus zq minus zp whole square, right? That's how we basically try to get the value of this distance PQ, right? So if you please solve it up and let me know with the answer. So did you get the answer the same that I am getting? So let me know. Let me know. Okay, so I got the value of the intercept. Okay, I actually have to find the length as well as the equation. Okay, so the equation of the PQ intercept is basically simply write this, right? So we have the PQ vector. So we have the direction ratios. We can just find that. So we have the point P and point Q. So we can just simply find the equation of the line PQ, right? And if we need to find out what is the length of PQ, so we got the length as, so if you just put the value of lambda and mu into this PQ equation, you can just simply solve it, or you can just simply find the magnitude of the vector PQ. You'll just get with the answer as, so I got the answer as 15 upon 3 units. And please make sure that you don't forget to write the watt units. Okay, whenever you are writing length, make sure that you are given in terms of the unit. If what unit is mentioned in the problem, please try to make sure to stick with that unit, right? If nothing is mentioned, you just leave it with units as the answer. Is it clear? Is this clear? Right? So this part is simple, right? So if we understand this part, let's move to that. So this was a 5-marker problem. Okay, so your entire marks was basically to analyze the problem, to understand the problem. Now when you're basically solving the problem in the actual examination, make sure that you draw the diagram, make sure you calculate the value of lambda and mu, and we basically mentioned that how you are basically solving the equation. Please label the equation as given equation 1, given equation 2, given equation 3, and on solving equation 1 and 2, we're basically getting that answer. So that's how you're going to represent your answer in actual examination. Please make sure that you do it right. And once you're writing the vector PQ, please make sure to represent the I cap J cap notation properly and clearly. Okay, and when you are doing the subtraction, please make sure that you don't jump steps. Okay, maybe many times you are jumping steps and you're getting the wrong answer, so make sure that you avoid that. Okay, so I hope you will basically take help of this particular solution and work on it on a given progress. Okay, so this was the problem of the very important problem. Okay, please don't skip this kinds of problem. Okay, this is a very important problem, and the way I'm basically showing you the steps, that's how you're going to write the answer or solution in the actual examinations. Okay, so make sure that you basically try to understand it. If you have any query, please post that in the live chat. I'm definitely watching your chats, and if you are watching this lecture after your recording, after the lecture live class is over, so you can definitely put that comment or the doubt in the comment section. Okay, I'll be basically helping out with all your solutions. Okay, so let's, with this, I hope you understand this, and let's move to the next problem. Right, now again we have a problem where it's basically a question on the angle between two straight lines. Right, let us try to analyze what is the concept of the angle between straight lines. So if we have two straight lines like given like this, so the angle the straight line basically makes, this and angle, let us call this as theta. Right, let us call this as theta. So this particular angle theta. Now in order to find the theta, we basically use the simple notation of vector. Right, so we have the direction ratio of the first line, let us call this as L1, and the direction ratio of the second line, let us call this as L2. Right, so if we have two vectors and we just need to find the angle between the vectors, we just use the simple the dot product. Right, so cos of theta is going to be equal to L1 vector dot L2 vector divided by mod of L1 divided by mod of L2. Right, that's what's your definition of dot product is. So we just use the dot product concept over here. Right, so we are given with the equation of two straight lines which are given as, so line 1 is given as x1 minus 1 divided by minus 3. I just interchange the x with 1. Right, so that's how we get minus 3 is equals to z minus 7 times of y minus 14 divided by some lambda is equals to z minus 3 by 2. That's my first line, and the second line is given as 7x minus 7 divided by minus of 3 lambda is equal to y minus 5 by 1 is equals to z minus 6 by minus of 5. That's how I have the two equations of the given line. Now I just need to simply put this direction ratios and find out what is the value of cos theta. Now you know that these are basically mentioned, this is basically straight, these are 90 degree. Right, so if the theta is 90 degree, so we just need to simplify the dot product as equal to 0. So if we just take the dot product is equal to 0, we just get the value of lambda, and if we get the lambda, we basically find out what is the given equation of the line completely, and then we have to check whether these particular lines are intersecting or not. So for lines to be intersecting, what is the given criteria is that the particular point at which the line is intersecting is basically lying on the both the straight lines. So that is what we are going to do over here. So let us see. Then if we try to find out what is this dot product and equal to 0, we basically get this as 9 lambda plus lambda minus of 10 equals to 0. So from here I'll get the value of lambda equal to 1. Right, so from here it's simple calculation. So for doing this calculation we get 1 marks, and you show the solution you get 1/2 marks. Right, this was a 3-marker problem. Okay, so you get the value of lambda. Right, now once you get the value of lambda, you can definitely substitute back the lambda into this particular given equation of line to find out the value of the given straight lines. Right, we have the two lines over here. Right, now let us try to understand that whether these given lines are intersecting or not. Okay, so to find out whether these lines are intersecting or not, let us consider that P line is given in terms of lambda. Let us consider this line 1 is equal to some lambda, and let us consider line 2 is equal to some mu. Right, and then we'll basically try to find out the same point by using the lambda and P notation. So for any point P, I can write that in terms of lambda as minus 3 lambda. So this particular lambda is different from the lambda. Okay, so maybe I just use some other notation. Okay, let us call this alpha and beta. Okay, if you might get confused, so let us consider as at alpha and beta. So this is going to be 3 alpha plus of 1 comma, so I have the lambda value, so this is basically going to be alpha plus 14 by 7. Okay, alpha by 14 by 7, and this is going to be comma 2 alpha plus of 3. Right, so this is basically the point P in terms of alpha, and similarly I will have the point P in terms of beta also. Right, so you can also write that point P in terms of beta as well, and once you get the point P in terms of alpha and point P in terms of beta, so both are the same points. Right, so you just need to equate it. Right, so from there you will get a value of alpha and you will get a value of beta. Right, so from that alpha and beta value, you just need to check and cross verify is the third z axis, the z coordinate is matching to the both the points P or not. So are you getting, for that particular value of alpha and beta, are you getting the z coordinate of that particular point P as equal, and that's going to be a check for the solution. Right, so what you basically need to do, so you have to just equate minus 3 alpha plus 1 to over here you will have this part as minus of 3 beta plus of 7 divided by 7. Right, so you just need to equate this part and this part equal, right? So you just equate these two parts and you just need to find out that for which value of alpha and for which value of beta am I going to get the same points, right? That's what your motto should be in this particular problem, right? I hope this particular problem is clear, right? So definitely mention the answer you are getting in the comment section. I'll be very helpful. I'll very hopeful for your answers, okay? And if you are basically representing answer, you're definitely going to get some bonus tips, okay? So let me know if you are able to understand this, or if you have any query, you can just put that on the live chat. I'm basically looking at your queries, okay? Okay, so please solve it entirely and tell me the answer you're actually getting, okay? So with this, let's move to the next problem. And the next problem is very interesting problem. I just need to find the distance between two straight lines, right? Now, I won't be solving this problem entirely, but I will give you the concept that what is the concept behind solving the distance between the two straight lines, right? And see, distance between two straight lines can be infinite, but when I basically mean to find a distance between straight lines, it is basically the shortest distance, or if the line is intersecting, then the shortest distance is going to be equal to 0, right? So whenever I have to say that distance in a straight line, I have to specifically mention that whether it is asking for the shortest distance or not, right? So this question was basically geared for asking the shortest distance, okay? So if we have two straight lines like this way, we know from our simple knowledge of application of derivative, the shortest distance between two lines definitely occurs along the common normal, right? So if I have any given point on this particular line in terms of a vector and the direction is given as L vector, and similarly this particular line is having the direction is M vector, and any point on this particular line is given as B vector, right? So if I have this position vector, so I can find out this particular vector, and if I need to get a perpendicular common normal, which is normal or perpendicular to both the lines, I will just take up perpendicular notation by just simply doing the cross product L vector cross M vector, right? So if I just do L vector cross M vector, I'm going to get a line which is perpendicular to both L and M, right? But that is going to be outer plane. That is not going to be in the plane of L and M, right? Now, in order to find the shortest distance, the shortest distance of point of the two lines is going to be simply the projection of this AB line onto this perpendicular line, onto this common normal. So this is going to be our common normal, right? This is going to be a common normal. This is very, very crucial problem, okay? Please make sure that you actually know the formula behind it and make sure you actually know the concept behind it, okay? So the concept of shortest distance is very crucial, not only for your CBSE examination, but also for your board exams, okay? Also for your JEE, what I mean to say, okay? Even in JEE or your state examinations or whatever engineering examination you're going to appear for, you can definitely have a question of shortest distance between two straight lines. That's a very common question, okay? So what is the concept behind it? We just need to find the projection of this particular vector AB. So what is our AB vector? So our AB vector is going to be vector B minus vector A, right? It's simply going to be equal to vector B minus vector A. And if I need to take a projection, so let us recall from our simple notation. So if I have a vector and I just need to take the projection of this vector A onto this vector B, okay? This is our vector B and this is our vector A. So the projection of any vector A, so let us call this A dash, okay? You might be getting confused, this A and B. So let us put it A dash. So any vector A dash on B dash vector is basically given as A dash dot B dash vector divided by mod of on which vector you are putting the projection on, okay? So that divided by that particular vector magnitude. So that's how we basically get the projection of the vector, right? So in this case, we are projecting this particular vector onto the common normal. So your shortest distance is going to be equal to D. Let us call the solution D, and that is going to be simply equal to B vector minus A vector dot L cross M divided by mod of L cross M, right? As simple as that, right? Now, if you just know the definition of scalar product, this particular vector product is basically the scalar product. So I will write it as scalar product of B vector minus A vector L vector M vector divided by mod of L vector cross M vector. So that will definitely generate me the shortest distance or the minimum distance, right? So that's how you're going to approach this particular problem, right? So I'm leaving this particular problem as a homework to all of you. Please make sure that you try to understand the problem, try to understand this particular way we are deriving the problem, try to understand this formula. This is very, very important, okay? I'm marking again and again. It's very important, okay? So make sure that you don't miss out on this particular formula. Okay, this was a 4-marker problem, so make sure that you recall and remember this part, right? So we have the two equations of given lines, we have the point A, we have the point B, we have the vector L, we have the vector M. So we have the given information, we just need to find out this particular scalar product and divide it by the magnitude of L cross M, right? As simple as that. So this is something of your homework problem. And one more homework problem I have with all of you. It's just a simple problem where you have to find out that a line is perpendicular to other line, and then you have to find a particular line which is passing through this particular line and parallel to a given line, right? So if it is parallel, you just need to equate that direction ratios to the multiple times of that particular direction ratio, right? That's the homework problem to all of you. Please make sure that you solve the questions and make sure you write the answer to the comment section. Okay, so you can do this question just after the class is finished. Okay, next problem we have with us is basically a simple problem from the equation of plane, right? So we have a given plane which is given as, so we have the equation of the given plane as x plus y plus z is equal to 5, right? X plus y plus z is equal to 5, right? And we have to find out the distance of point P from the intersection of the line joining this point and the plane. So we have some line and a plane, right? So we have to find out the equation of the line AB, and then we have to find out at what point this particular line is intersecting this particular plane. So let us consider this point as C, and then we have to find the distance of the point P. So P is some unknown point, minus 5, minus 1, minus 5, minus 10. So we have to find the distance of point P and this point C. So this is what the question has to talk about, right? So what we'll do in this question is that we'll first try to find out what is the equation of this line AB. So I'm writing the steps over here, and I expect that you will basically solve this problem on your own. Okay, so I will first of all write what is the equation of the line AB. So once I get the equation of the line AB in terms of some like this way, so once I get the equation of the line AB, I just equate to some lambda constant. Okay, and then I get any general point in this particular line as some alpha lambda plus B plus A comma some beta lambda plus B comma some gamma lambda plus C, right? As any point in this particular line, right? And I just put, since this particular point is lying on the straight and the plane, so just put the value of the given line into this equation of plane, and I will solve for the value of lambda. Okay, solve for lambda. So once I get lambda, I can definitely find what is our point C, and once I get point C, I can definitely find what is the distance by using the distance formula, right? So as simple as that, right? So one more homework problem for all of you. Right, so you have 3 more homework problems for today's class. So make sure you solve these problems and come up with the class. Okay, is it clear? So with this, let's end our discussion of 3D geometry over here. I hope the discussion of 3D geometry by discussing the previous problem was fruitful enough to understand all the important concepts that are basically definitely important for your CBSE examinations. Okay, so if you are making sure that you know the basics, you are basically revising the problems or the previous problems with me, and you are basically watching this content, you're definitely going to see that there is definitely a good booster or a kind of a confidence you're definitely going to gain after this particular lectures are over, right? So please make sure that you follow all the lectures in a proper order, and you make sure you understand each and every problem. If you have any query, definitely put that up in the comment section. I'm always there to help you out, right? So let me know if you are clear with all these parts. So with this, I hope all of you are good to go with the chapter of 3D geometry. So we will have one more session on 3D geometry where we will discuss more on the questions of planes, right? So today's class, you saw that more of the questions were on the straight lines in 3D space, right? So we'll also see questions of planes, right? So you will have one more session on 3D geometry. So make sure you are basically tuned for that particular concept of that. Okay. So don't forget to subscribe the channel, and if you find this video useful and helpful, make sure you like the content right now. Okay. All right. So with this, I wish all of you good luck. So let us end our lecture.